welcome to the channel Knowledge Star, Continuous Knowledge Excellence. My name is Nisha Masroor. In this video, we will get to know about common polymers used for nanogel synthesis. Now, our expert Professor Bohidar, who is associated with National Center Excellence in Agro Nanotechnology, Terry Daikon Nanotechnology Center, India. He has 31 years of academic experience in teaching and research. His area of expertise includes nanoscience and nanotechnology, nanobiointerface science, soft matter science, polymer physics and biophysics. We'll explain you in detail about this topic. So, to get complete information, watch full video without a skip.
What are the common polymers that are used for nanogel synthesis, particularly when it comes to application in biology? These are some of the identified polymers which are very commonly used for the synthesis of nanogels, and they have found applications in biology with the acrylic acid, polyacrylate, polylactide, glycolide, polyglutamic acid, polyethylene, all these things, polyethylene glycol, chitosan, pectin, these are biopolymers, hyaluronic acid, these are all biopolymers. And so this is on the top layer you see the synthetic polymers, and the bottom you see biopolymers here, and also glutamic acid also is a biopolymer. So with combination of all these things, this is only a partial list. I don't have the full list here, but this is just indicative to tell you that these are the types of polymer that are used in the formation of nanogels. So we'll start with very, very simple example and try to build up this story further. Okay, so these are various types of templates that one can create using these surfactants. I do not want to go deeper into the subject because that's a domain in its own right. So we can have a completely hollow structure where we can put a nanogel. We can have several layers kind of structures here, and various other conformations are possible. But everything depends on the precursor that we are choosing, the organic phase we are choosing, and the surfactant we are choosing. Now, the polymers that I identified some of these things in the previous slide, they have some certain properties. That's the reason they are chosen for nanogel experiments. And these temperatures that you see on the right hand side here, these are indicative of the gel transition temperature, means they remain as a gel below this temperature.
Wait. Are you worried about your project, training, dissertation, internship? Don't think too much, because Nanoscience and Technology Consortium, in short NSTC, is giving you a golden opportunity to do the same tasks. NSTC also conducts workshops on amazing topics. So if you want to register in the workshop, the registration link is given in the description box below, or you may go to the website www.nanoschool.in, where you can easily enroll in the workshops. So just check it out right now.
Okay, above that they turn into liquid phase. So these are the requirement that one has to match ultimately to get successfully a nanogel in an experiment. Now, after the nanogel is formed, the next task is to load the active agent inside it, which can be a drug molecule, an enzyme, or any other thing that you would like to load inside the nanogel. So symbolically, what is done is that at the time of the cross-link formation, we also load the active agent in there, because the nanoreactor is already there ready for us to be utilized. So when you put the loading agent with the polymer together, they get trapped inside, then they translocate themselves into the core of the nanoreactor. And then you do the cross-linking experiment, and then you will definitely achieve a situation where the nanogel will capture all these drug molecules and will get more or less homogeneously distributed inside the matrix of the nanogel. This is what is being pictorially shown here. Okay, once that is achieved, in the next step, we take out all the surfactants from the surface because the job is already done. This is a stable particle here. This cannot disperse. It has got both solution and temperature stability. So removing the surfactant layer, which was providing the template, is quite easy. By dispersing it in an organic phase, it all be washed away. Then you have a water dispersible nanogel ready for application. The story does not end there, because once you have loaded the drug, next thing is to release it when goes to the target. So for that, when we want to do the cross-linking processes, we need to have certain triggers available, so that you can press the trigger and break the cross-links, and then we are able to release the drug into the right place, right site. So there's a targeted drug delivery. So there are various ways of doing this triggering. So again, this triggering will depend on the polymer that we have chosen, on the cross-linker that we have utilized, because the cross-linking is the one that is holding the polymer together. So you have to basically destroy the cross-links. So it can be triggered for certain polymers by changing the pH, by hydrolysis, by temperature, by exposing it to ultraviolet radiation. It depends on what type of bond we have formed during the cross-linking process. This is what I'm trying to focus on. Okay, so this is basically a summary on this slide of the type of cross-linker we have used and type of stimuli we need to give to the system for the drug to be released at the site. Okay, this all goes in the background information.
I hope you like this video. Further, I would like to give you an important information that Nanoscience and Technology Consortium organize the nanotechnology workshops on very interesting topics. Also, I would like to tell you about the initiatives of NSTC, in which you can also be a part of. Mentorship, patent commercialization, joint product development, research projects, consultancy services, nanomaterials for your research projects, training programs or customized training programs, workshops or customized workshops. So that's all. If you want to see these type of videos, then please do comment. We will definitely reach out to you. Subscribe to the channel on Star and also hit the bell icon to never miss an update. Thank you.
For more updates, subscribe to our channel, click the links shown on the screen to stay connected.